Hello everyone, welcome to the channel TopGate. In this video we will discuss CPU scheduling, and if you go back to my previous lectures where I have discussed about the state transition diagram of the process. So in that diagram, if you see, when the process starts from the new state, then in the new state it tries to acquire all the resources it requires for its completion. After it completes its resource requirement, it migrates from the new state to the ready state. So in the ready state, it is now waiting for its turn to be executed by the CPU. Now as soon as the CPU scheduling algorithm picks that process from the ready queue and it sends it on to the CPU, so the process executes there on the CPU, and then from the CPU it has two options. Either it can complete its work and terminate, or the second option is that if for its completion it requires some input output devices, then it leaves the CPU and it goes to the waiting state. Fine. And in the waiting state it tries to use all its input output devices and then complete its work, and then again it goes to the ready state, and from the ready state it again goes to the CPU where it completes its execution. Fine. So the time for which the process is executing on the CPU is called as the CPU burst, and the time for which the process is using the input output devices is called as the IO burst, input output burst. So the process in its lifetime, it migrates between two CPU bursts and IO bursts. That is, its journey starts from the CPU burst, then again from the CPU burst it may go to the IO burst, and then to again CPU burst, and then again to IO burst, again CPU burst, and finally it terminates its work at CPU burst. So you can see in this one, for the first part of its life, it works on the CPU. That is, after going on to the ready state, it straight away goes to the CPU and it does its work on the CPU. So that is called as the CPU burst. Now after doing its work on the CPU, it has two options. Either it can complete its work and terminate, or it can go to the input output and use the input output devices. Fine. So that is the second part. So this is the input burst. That is the time for which the process is executing on the input output, or the time for which the process is using the input output devices is called as the input output burst. Now after completing its work on the input output, it again goes to the ready state, and from the ready state it again goes to the CPU where it completes its work on the CPU. Then there is a CPU burst. Now from the CPU burst it again goes to the input output burst, then again to the CPU burst, again to the IO burst, and finally it completes its work on the CPU burst. So let's try to understand this point wise. The first point says that the execution on the CPU starts with the CPU burst and ends with the CPU burst, and in between, that is CPU burst and the CPU burst, and in between there may be a sequence of input output and CPU burst. Maybe means that after completing its work on the first CPU burst, the process has two options. Either it can terminate or it can go to the input output burst. So that is why I have written that there may be a sequence of input output and CPU burst. So that is the first point. Second point says that the CPU bound process spends more time on the CPU. That is, we have two kinds of process. First process is a CPU bound process. Second process is a kind of output bound process. Fine. So if we say a process is a CPU bound, that means the process in its lifetime spends more time doing the CPU work, getting executed on the CPU. That is, suppose there is a process which needs to do some heavy calculation. So for that heavy calculation, it will, for its most of its lifetime, it will be executing on the CPU. So that is called as a CPU bound process. That is, it is very less. For very less time it is using the input output devices. Most of its time is spent in doing the CPU burst only. Now third thing is the input output bound process spends more time doing the input output. That is, suppose there is a process which needs to print some pages, print some documents. So while printing its document, this process will mostly work on the input output. It will not work on the CPU more, rather it will work on the input output more. So a process which spends more of its time on the input output devices or on the peripheral devices, that is called as the input output bound process. Now, the fourth point says the scheduler should select process in such a way that there are some CPU bound process and some input output bound process. That is, the scheduler which is there, it should select a process in such a way that we have a variety of both kind of processes. That is, we have some processes which are CPU bound, we have some processes which are input output bound. The process in its lifetime, it does two works. Either it is getting executed on the CPU or it is doing the input output devices. But in this operating system, we'll only be dealing with the CPU bound process. We'll not be dealing with any kind of input output bound process. But that does not mean the process is not doing input output. The process is doing input output also, but we are only sticking to process which are CPU bound. So we are only considering the process which are doing their work on the CPU, and will be ignoring their work which they are doing on the input output. So the example of input output can be, suppose you go to ATM. Now in the ATM, you suppose you want to dispense some cash. As soon as you go to the ATM, that ATM will first ask you for the card. Asking you for a card is actually, this process is doing the input output. It is now requiring the input from the user. So when it is asking the user for the input, it is not working on the CPU. It is doing the input output, or it is waiting for some user's input. Now after you insert your card, then it will again ask you that is it a savings account or is a current account, or what kind of currency you require, or how much amount you require, what is the password of your card, all those things. So all those things, that is, that process, that dispensing cash from the ATM, this process is actually a input output bound process. That is, in its lifetime, most of its time is spent on doing the input output. So that process can be termed as the input output bound process. But suppose we have a process, and in that process we need to calculate, we need to do some very heavy calculations. Now in those heavy calculations, this process will spend most of its time, most of its lifetime doing the CPU work only. It will only ask some input from the users, and apart from that, it will most of its time doing the heavy calculations. So that process can be termed as a CPU bound process. Clear? So this is the concept of CPU scheduling, and in the next upcoming videos we'll be starting with the designing of the algorithm. All our lectures of CPU scheduling will be based on the state transition diagram of the process. So in that process, we know that there is a short-term scheduler which is responsible for sending the process from the ready queue to the running state. That is, from the RAM, it is sending the process to the CPU for getting executed. So the short-term scheduler is responsible for picking the process. Now this short-term scheduler is picking the process on the basis of some CPU scheduling algorithms. So we are trying to develop some CPU scheduling algorithms. So in the next video, we'll try to understand what is the scheduling criteria on which we'll be trying to make the algorithms. So these algorithms, when they were developed on the basis of some scheduling criteria. So I'll tell you all those scheduling criteria, and then finally we will move on to the CPU scheduling algorithms, where we'll be discussing FCFS algorithm, we'll be discussing shortest job first algorithm, we'll be discussing priority and round robin algorithm. As well as in the next video, we'll also discuss about the two kinds of scheduling. There are two kinds of scheduling. One is preemptive and one is non-preemptive. So we'll be discussing all those kinds of schedulings, and this topic is one of the most important topics in the operating system. These concepts are they are usually asked in GATE exams, NET exams, many competitive exams, as well as it is always asked in the semester exams also. Thank you so much.